Good day everyone. I am John Carlo Calo and I am taking up Bachelor of Science and Secondary Education. So our topic for today is all about how relativity of simultaneity and length of a contraction are related. So this topic is we're going to discuss together with my partner Rochelle Gamos. So this is our objective. So first, discuss the nature of relativity of simultaneity and length of contraction. Second one is evaluate the importance of simultaneity and length of contraction in a real life situation. The last one is demonstrate understanding about relation between relativity of simultaneity and length of contraction. Relativity of simultaneity. In physics, the relativity of simultaneity is the concept that distant simultaneity, whether two spatial separate events occur at the same time, it is not able or it is not absolute but depends on the observer reference frame. This possibility was raised by mathematical Henry Poincare in 1900s and therefore become a central idea in the special theory of relativity. According to the special theory of relativity introduced by Albert Einstein, it is impossible to say in absolute sense that two distant events occur at the same time if those events if those events are separated in space. So, for example, we have a car crash in London and the other in New York. So, appearing to happen at the same time to an observe on Earth will appear to have occurred at a slightly different time. To observe on an airplane flying between London and New York. Furthermore, if two events cannot be causally connected depending on the state of motion and crash in London may occur first is giving frame. So, ang pasabot dana is even if same time mo nahitabo pero um, 'di ba ang earth ga circulate, so like for example diri sa Pilipinas is 8 a.m. but sa America is ang literally like for example 8 a.m. dire and then um nay na disgrasya dani and then didto is nay na disgrasya pod. So dili man pareha og time because of the earth is circulate, so dili pareha og time pero um literally is same event ra nga na disgrasya pero dili siya same og time. What is the cause of relativity of simultaneity? Relativity of simultaneity can purely due to the fine speed of light. What does the simultaneity depends on? It depends on the observer's reference. So that would be all for the relativity of simultaneity. So for the length contraction, Ms. Gamos will explain more about what is the length contraction.
Good day everyone, I am Rochelle Velasco Gamos, and today the next topic that I'm going to discuss is all about the length of contraction. So what is the length of contraction? The length of contraction is the phenomenon that a moving object's length is measured to be shorter than its proper length, which is the length as measured in the object's own rest frame. It is also known as Lorentz contraction or Lorentz-Fitzgerald contraction after Hendrik Lorentz and George Francis Fitzgerald, and is usually only noticeable at a substantial fraction of the speed of light. So for example, the wheels which travel at 9 to 10 the speed of light, the speed of the top of a wheel is 0.994, while the speed of the bottom is always 0. That is why the top is contracted relative to the bottom. So, the length contraction is observed when an object is moving at speeds close to the speed of light, while the observer is not. This is because of the relativity of space and time. So, an observer viewing a moving object will receive signals such as light from the two extremes of the object at slightly different time intervals. Thus, the observed length of the object can change based on the object's speed. So, for example, in relativistic physics, length contraction is when a moving object's length is observed to be shorter than its actual length. Actual length is defined as an object's length in its own rest frame, while the observed length can be significantly shorter if the object is moving at speeds approaching the speed of light and the observer is not. What is the purpose of length contraction? So, the length contraction is the measurement of position made at simultaneous times according to a coordinate system. This could suggest that if one could take a picture of a fast-moving object, that the image would show the object contracted in the direction of motion. And the conditions of length contraction is that length contraction occurs when a moving object observed length is shorter than its proper. The amount of length contraction of the object purely depends upon the object's speed relative to the observer. And again, the length of contraction is observed when an object is moving at speeds close to the speed of light while the observer is not.